How's it going, everyone? If you ever wondered how to create a 2D platformer game, or any video game for that matter, I have you covered here today. Alright, now this video is going to be beginner friendly, however it will pick up on the second half of the video. And for those of you who are new to game development, a 2D platformer is probably the best genre or best type of game you can create on your own, as it's not too complex and it's not too easy of a genre to create. It's somewhere in the middle. It's like a happy medium when it comes to video game development. Alright, well, before we jump into the tutorial, check out this demo of what's to come. Alright, as you see here, we will be creating character movement, gravity, collisions. Something pretty cool here is the jumping mechanics, which is going to be optional, as you'll see later on in the video. But what we have here is what I like to call Super Mario jumping mechanics, where the player performs a large jump if you tap and hold the space bar, or if you just tap the jump key, in this case the space bar, you'll perform a very small jump as extra gravity will be applied. Another cool thing here is we have one-way objects. So this crate, for example, instead of colliding with it as like a wall, you can walk through it. However, you can also jump and land on top of it, and you can also jump through it. And so this is great if you're ever creating a game where you need to jump through platforms, or if you're already on top of a platform and you want to kind of jump down or fall through it, you have that logic there. And lastly, I'll leave you guys off with some ladder climbing mechanics, just a way to improve your insight on how you can tackle adding new features into the game, and how to update or change existing code to kind of tailor your needs. But pretty much when we're climbing the ladder, gravity is going to be turned off, the player's animation is going to stop unless you're climbing, and there's logic in the game to where if you're getting to the top of the ladder, your character just kind of jumps off or gets off. And same thing when you're climbing down, your player will just kind of drop. An additional treat here I toss into the game, which I'm going to leave for you guys to figure out, is going to be slopes. Now, a disclaimer here: if you're new to game development, or math is not your best friend, I would advise you to stay away from slopes. This is because if you're implementing slopes in your game, you can easily add blockers, increase complexity, or increase the scope of your game. However, if you're up for the challenge, the code we'll be going over today has very basic slope mechanics in place. However, you would have to add on top of what has already been created. And if you want, I can also talk a little bit about slopes and slope mechanics in another video. Alright, and so that's pretty much what we're going to be getting ourselves into today. And with that being said, let's start the tutorial. And so very quick, I put together this presentation of just a few slides to kind of explain what game engine we're going to be using, what is a platformer, and start to talk about some of the fundamentals of a platformer, and then go over today's agenda. So creating a first 2D platformer, we're going to be using the GameMaker Studio 2 engine. The engine is free. I have a refresher video on my page. I'm going to try and post it somewhere on the screen now. If you guys want to understand some of the fundamentals of GameMaker Studio 2, you're kind of new to the engine, definitely check that out. This engine is specifically used for creating 2D games. You could create 3D games. I would advise you not to do that. Next up, what is a platformer? So a platformer is a type of game. It's a genre characterized by gameplay involving, and I put this in bold here, guiding a character across platforms, typically by jumping, running, and climbing. And so a few examples, I also put this on the bottom in bold, but some examples include Sonic the Hedgehog, Super Mario, Mega Man, Rayman, Donkey Kong, Kirby, Crash Bandicoot, and Ratchet & Clank. These last two examples are 3D platformer games, so definitely check that out. Next up, fundamentals of a 2D platformer. So here are some of the fundamentals. We want to create platforms, jumping mechanics, obstacles and hazards, enemies, collectibles and power-ups, and level progression. Level progression is a big one. A lot of people struggle with game design or level design. So my challenge to you actually would be create a tutorial room and kind of teach the players the mechanic, or have an obstacle where a player needs to learn the mechanic and use it before they can proceed on to the next part. And some examples here are Super Mario Bros. Created by Nintendo. This is one of the most iconic platformers, where you control Mario and navigate through levels with the main goal of rescuing Princess Peach. And what makes all of these platformer games stand out is something very specific. So when it comes to Mario, Super Mario is a very vibrant game, and also it's very technical. It's a very technical platformer. It's one of the first platformer games too, especially on the Super Nintendo, and the most iconic. Alright, so for today's agenda, we're going to create a player, implement player movement, create platforms in the ground, handle collisions for collision logic, and try to create some interactables. I'm not going to create many, I'm just going to kind of get the basics out of the way and then kind of leave that up to you. Alright, so creating a player sprite. In GameMaker, sprite and objects are separate assets. And so how GameMaker looks at it is that you're going to import your sprites or your images, and what you're going to do is assign them to objects and then give logic to the objects in the game. Next up, the origin point. Whenever you're creating your character, you definitely want to put the origin point at their feet because that's going to be used for handling collisions. You don't need the origin point at their feet, but it's great logic wise whenever you're creating code that you can just reference the origin point rather than doing a bunch of math. Next up, create a player sprite object. So we're going to create the object after the sprite's been imported and defining some basic movement variables. I'm just going to go through the rest of the slides here so that way this video doesn't take too long. But next up, we're going to implement player movement. So horizontal movement, jumping mechanics, and adding slopes. Tailor it to whatever you're looking to make. Next up, creating platforms and ground. So this is where we're going to create the collision objects. Same situation, you're going to create the sprite, the images, and then you're going to attach it to a ground object. And then lastly, adding ground objects in the room for this slide. Next up, handling collision with the ground. So what we're going to do is we're going to create one object and use it as the wall, the ground, all of our collisions. And then we're going to create one-way platforms. So as you saw in the a few minutes ago, you can jump on top of the crate and then drop below the crate. And then lastly, interactables, coins, collectibles, enemies, power-ups. I don't see us creating many interactables as you saw inside the demo a second ago. Definitely have the ladder, we have the information post. Some of these are pretty basic and straightforward. Maybe another video I can tackle some of these if you guys are interested. And then lastly, I'll leave off the video with my challenge to you. So I want you to create your own enemy, create slope logic, perhaps create double jump logic, add some collectibles, and create some score system, so on and so forth. For this video, we're going to be using, and I have the honor of using, Dan Vesasquel's art over at Dan Vesasquel Art. He has many different social media outlets so you can check him on, but definitely check out his itch, and he's constantly creating new artwork. I'll put all the links inside the description here, but for this video, we're going to be using the thick and juicy asset bundle and also the deep and dark asset bundle. Visit this page, download now, continue, download now, continue. And if you like his work, consider picking up an asset, showing some support, and let's jump right into the game. Alright, so after launching GameMaker, you want to click on Game, Blank Game, and we're going to give this a name. Let's call it Platformer 2D Game. Call it whatever you wish. I'm just going to hit yes here. And so again, if you are new to GameMaker, this may be overwhelming at first, but definitely watch out the fundamental videos. I'm going to try and explain as much as I can as we go on. But what we're first going to do is start off by importing our assets and start to build a room, and then we can kind of add logic from there. So we're going to go on the very right side on the asset browser, right click where the sprites are created, where the sprites folder is. Go to create and click on sprite. And here, we're not going to click on import. We're going to click on edit image on the top where it says image. We're going to go down and click import strip image. It's going to open up your Windows asset browser. And from here, what you want to do is click on the thick and juicy free character pack. Click on open. And let's put in some values. So every time you start to work with assets for games, you're going to notice that the character is always facing one way. The character should always be facing your right or the character's left. Character should only be facing one way, and we're going to add some logic in the game that's going to flip all of these assets so that way you can walk in the opposite direction. You don't have to recreate all of the animations over and over. However, we have an asset sheet. We need to break up this asset sheet into many different frames. So what we're going to do here, just follow along. I'm going to put in 39, 12, 32, 32, 0, 0, 8, 16, 0, 16. And so what we have here is we're just kind of putting in these values so that way GameMaker can properly scope out all of our frames. click convert. I'm gonna click here to minimize this to create some more space for us. And then same thing with the sides here. And so now if you hit play, you're gonna notice that all the frames are playing at the same time. So what we're gonna do is right click on sprite 1. You're gonna go to duplicate, Control D, and just create a few duplicates. Ultimately, you should end up with 6 in total. Bit of a shortcut, Control D. And let's start off by naming them. So let's go with S. You double click on them, or you can slowly double click and you can change the name here. So for the first sprite, let's start off with S_player climb. And what we're going to do is find the climbing sprites, and that's all we care about. So it's just the last 3 frames. Delete all of this stuff here. And mainly we just want these 2 frames, and then the climbing done can be separate. So we don't want this one. But I'm just going to duplicate this actually one more time so that we don't have to delete all those frames. I'm going to climb this one called climb done. And so when we're climbing the ladder, and also think about jumping, when you're performing some of these animations, they're broken up into different pieces or segments. In this case, you're climbing up the ladder. You never want to trigger climbing done. So in your code, you want to say like, you're going to alter between frame 0, frame 1, or the first 2 frames. You never want to hit the last frame. In this case, just to avoid that, I'm just going to delete that from here, and then keep it here. So when we're climbing up a ladder, it just continues to play these 2 frames as we're climbing, and then once we're done, we can play this frame. Alright, so I'm going to pause the video here. What I want you to do is create a S player idle, jump, landing, jump, and walk. Alright, so now we should have our 6 sprites here, or 6 sprite assets. We have climb, climb done, idle, jump, land, jump, and walk. Make sure to set the origin at bottom center. So that's your XY origin. It's going to tell you where that is right here, 16 by 32. And in case you're wondering what jump versus land jump means or looks like, here goes jump. Your player's going to jump in the air, and you don't want the player to continue cycling through the jump or land until the player actually lands. So the player is going to be stuck right here, or if you have different animations you want to toss in where the player is kind of like gliding a bit, you can do that as well. But for this video, we're just going to stop the frame here when we're jumping, and then once we land the jump, just these 2 frames. Right, next thing we want to do is start to modify what is the FPS, or the frames per second speed on these animations. And so I found 5 to be fine for everything but the jumping asset. And so if you play this here, this is what 5 FPS looks like. You can also modify this 5 FPS in code. You can say set that to nothing, multiply that by 2, 3, whatever. Next up, let's put this in the bottom center. Next up, we're going to go to collision mask, and you're going to notice that GameMaker is going to automatically try and mask your sprites for you. But if you take a look here, you're going to notice that this collision mask is different from, let's say, the jumping collision mask. Well, this is modified, but if these will be like 2 good examples here. This collision mask is different because now the bottom piece is not even accounted for, versus here the bottom piece is accounted for. So what we want to do is set all of our assets to bottom center for the XY origin, go to collision mask, set this to manual, and we're going to put in some values here. We're going to put in 9, 12, 22, 31. This is going to be done for all of the assets. And why do we want to do this? As I mentioned a second ago, if you're jumping, or in this case, if you're climbing a ladder, and then you switch to this animation, GameMaker thinks that this is a different object. What's happening is the collision mask is less. So now there's a chance when you switch back and you add that extra collision, you could probably clip through a wall, clip through the ground, or whatever. And so we don't want to clip through anything. We want to have precise logic for all of our sprites when it comes to the character, and avoid any situation where we are going to clip towards anything. So again, you want to go to collision mask, manual, and then set these up to, again, 9, 12, 22, 31. Let's do that and come back. All right, looking good. Next up, we're going to right click on sprite again, create sprite, and this time we're going to import. And let's bring in that tile set that we have here. So now we have a tile set, and we also have some items here that we can use. And so what I'm going to do is I'm just going to duplicate this sprite and keep this as a placeholder for now. And if you want, you can go ahead and delete all this extra stuff, or you can keep it there. Maybe we can create multiple tile set layers for some of the items or assets that are just supposed to be as decor. But we definitely want to create a ladder object in the game. We definitely want to create a create object, a information post. Some of these other ones, you can kind of do whatever you like with them. I'm just going to go here and click on auto trim frames, and then we can kind of mess around with this and break them up into separate sprites, but we'll do that later. Let's first start to work on our room. So here we have our sprite. Let's call this T for tile set underscore, we'll call it cave. We'll call it S cave. We need to create a tile set with this sprite. And notice I have the same naming convention for all of these sprites. I'm just going to keep them as S underscore whatever. So I have cave here, and then where it says tile sets in this folder, I'm going to click on create tile set, and you can click and drag if you'd like, or you can try and find it through the properties like directory folder thing that GameMaker has. On the right here, you're gonna notice that you have a tile width and height set to 16 pixels by 16 pixels. That's perfectly fine for this project. I'm gonna click on Control S to save. Next up, we're going to go to our room. We're gonna start setting up our room. And so GameMaker automatically creates a blank room for you. This is room number 1. And what I'm going to do is I'm just going to modify this room a bit to tailor our needs. So let's do 768 by 640. This is just creating the width and height of your room. For pixel art games, you'll most likely have smaller rooms. But anyway, viewports and cameras. And so what we're going to do here is we're going to enable viewports and cameras. We're not going to create our own camera in Logic. We're just going to use the built-in GameMaker logic here, and I would definitely advise you to go online and check up a camera that works for you and start to code and implement that. But for right now, we're going to do something very basic, very simple, and you're going to notice that all of a sudden when you click on visible, we're saying viewport 0 is now visible in the room, and you're going to notice that the camera properties are picking up everything in the room. We don't want to pick up the entire room, we just want to pick up a bit of a section in the room. If you want to pick up the entire room, you can. But typically in most games, you're not going to see the entire map. So what we're going to do here, since we're working with a pixel art game, let's do 320 by 180. And then this is what is going to be shown on screen. And what we want to do is, what are we going to export on your actual, like when you hit play, what resolution is that game window going to be? And for right now, we're just going to make it 720p. It's a 1280 by 720. Nice clean numbers. And next up, we're going to have an object that the camera's going to be following. It's going to be the player. So for right now, we're going to click on create, where the objects folder is. Create an object. We're going to call this O underscore player. What we're going to do here, let's put in the idle frame here. This should be fine. You can toss in the idle sprite asset. Now what we want to do once we're here, let's go back to viewport 0, open up the room again, and bring in the player object. Definitely toss them in the room. Here's fine. And you're going to notice whenever you start playing the game, the horizontal and vertical border is going to be way too small. And once you start running around, the camera isn't following as it should. And so what I'm going to do here is just put 156 by 156. I found this to be decent values for this game and resolution. And so when the player walks now, the camera's going to try and center it a bit, rather than you're walking here and then the camera is still not following along until there's 32 pixels near the border. Put the player here for now. Next up, for background, what we can do is, see where it says color, let's just create a fun color. Alright, so next up we're going to create a collision sprite, and we're going to create two of these. S underscore, let's call this wall. We can call it COL for collision, ground, GND, whatever. We're just going to call it wall for this video. Do we want it at 64 by 64? That may be too large. Let's make this 32 by 32. Apply, and let's pick any color. I'm just going to go with orange here. Whenever I create collision objects, I like to give them an alpha so that way they're somewhat transparent. So I'm going to set that to 180. Left click, fill tool F, left click here, and then we're going to go with text. Take out anti-alias, and that's fine. Just going to put here, black is fine. Just going to put C for collision. Next up, we're going to just duplicate this, because what we're going to do is we're going to create a second wall, or a second collision. You can kind of name it whatever you like. Green's fine. Set this to 180, make it slightly transparent. Fill, toss that in there. We don't need the first frame, you can delete it. Change our color to black, and we're going to call this one C2. Let's try right here. Collision 2. Or wall 2. W2. Whatever you like. Now the index can stay at the top left, that's fine. Nothing's wrong there. But in the objects folder, now we need to go ahead and create two separate objects. So let's toss in swall. Just going to duplicate that. Let's toss in swall, or collision 1 and collision 2 sprite. And so what we're going to do now is give these objects names. Let's go O underscore wall. That's fine. And then O underscore, let's do wall, not wall 2, but wall one way, because you're going to be one-way platforms. Next up, let's just create while we're here, notice that we duplicated one of the assets that we brought in earlier to just bring in some of these objects. So what we're going to do is now, let's create the crate, break this out into its own object. I'm just going to copy it. We can also copy all of this stuff. I'm just going to create this as separate object. So what you want to do is use this click and drag tool, copy, create a new sprite, and we can do like 128 by 128, and just bring them in. So I'm going to fast forward some of this stuff. It's just going to be a matter of you bring the sprite in, you clean it up, you go to image, auto trim frames, and there goes your crate, and then you can continue doing that. And for right now, just create the crate. When it comes to the ladder, what you want to do is create one more sprite here. You want to try and alter the ladder a little bit. How we're going to do that is you just kind of play around with your asset here, copy some of it, and then kind of extend it like this. You just modify it, paste it over itself. I think that looks good. Image auto trim. Let's go back to our room, and what we're going to do is on the left side where you have your properties, click on create new asset layer, new asset, and let's bring in this tile set layer. And so here is where we'll start to create. I'm not going to spend too much time on this. You guys can kind of, however way you'd like, just kind of show you guys how some of this stuff works. There you go. And also, if you want, you can start to add some of these other non-items into the game on the tile set layer. You can also create another tile set and put them on their own separate layer if you want code that can interact with this tile set layer. All right, Control S to save. So let's go back to these two collision objects. And so we have wall and wall one way. If you click on the eyeball for tile, so you can make it invisible, but let's also put this instance layer above the tiles. Excuse me. So we can see, just gonna click and drag the collision object. Hold control if you want to get precise. And I think this is fine. Now you can see these are the collisions. You can continue creating them as you wish, but for now, if you click on instance layer and uncheck this one, it'll now be invisible. You can also go here and then make this invisible by also unchecking visible in the properties of the object itself. In this case, I like to create two instance layers, one for the collisions, one for the player. So let's get the player and just delete them from this instance layer. Toss them in here, because ultimately our goal is to make it so that these collisions, this whole layer is just invisible, just using it for collisions. And while we're here, let's go and create two more objects, O_ladder and O_crate. Just gonna toss the ladder in here for ladder, toss the crate in here. So the ladder doesn't need anything special to it, but the crate, we're gonna take the parent and we're gonna set the object to O_wall one way. So that means the one-way collision is going to be applied to all of the crates in the room. And for right now, I'll toss in, we can put it on this instance layer because it's not supposed to be invisible, but we'll put it here for now. Then we'll put one floating up here. We haven't done anything yet. Let's go in the player. What we're going to do is start coding. All right, so first thing first, we're going to go to add event. There's a bunch of different events you can utilize in GameMaker. We're going to click on create event, and what happens with the create event is it only gets initialized once whenever this player is created. So I'm going to copy and paste here some code and then explain what our variables are. And these are variables that we're going to reference in code. So as you see here, I'm going to go and click on this expand or maximize window. I can minimize this for now. I guess it doesn't matter. So what you're going to notice here is we have a bunch of different variables. So we're going to have player player Y speed, player X speed, gravity, and a bunch of others. And so we're going to use this later on, and Y speed should be set to 0 because the gravity is going to be applied to it at all times. Max fall speed, we're going to set that to 8 for now. These are some nice variables I found that make the game look nice. Definitely mess around and play around with it as you wish. Jump speed -7, climb speed 2, and you may be wondering, why is jump speed -7 and why is fall speed 8? Why is fall speed a positive number? Why is jump speed a negative number? And that's because in GameMaker the Y values are flipped. So if you guys are used to like coordinates, if you look at a graph here, if the player is over here, I'm just gonna do a very basic object. If the player is over here, just gonna put Y. We need to calculate where they are on the map. So this is your X axis, this is your Y axis. The only difference is in GameMaker, Y axis, for example, let's do -10. When you're going up in GameMaker, you're going into a negative Y value, and then when you're going down, you're moving positive. X is still the same, so you have X plus 10 here and X minus 10 here. And so when you're jumping, your player right now, let's pretend your player is like on X5, so coordinate like 5, -5. When you're jumping into a negative value. You're going to be jumping to -12, for example, you're jumping up 7 pixels. And then when you're falling, you're going to be adding to the player's Y position. And so that's how we get 8, -7. Climb speed is 2. We're going to have separate logic for that. Depth, -9. Feel free to change this however way you wish. I like to put -9 for the player whenever I create games, just so I can keep track of what the player's depth is. Jumping, this is just going to be a variable to say for jumping or climbing. Also, when it comes to depth, the negative number, so this is another thing to remember. When you have depth, let's pretend we have two different players here, two different objects. Object in front, the one that will appear on screen, is most negative. So in this case, -9 would appear first on the screen. That's the only negative object in the game when it comes to depth. The one behind it is like +100 or whatever. It's going to be way in the back. And you can see that if you open up your room, start off in the top left, you're at 0, 0. And it's right here in the bottom, by the way. You move right, you're moving +X. You move up, you're going -Y. You move down, you're going +Y. You move left, you're going -X. And so your player is essentially on a grid. You need to tell the player how the player is going to move on the grid that it's already on. Lastly, player sprite animation. So we have idle, climb done, player jump, land jump, and walk. And so I like to create separate variables here, so that way if you ever want to reference them or change them later on in the game, let's say you're in a particular room in the game and you want the player to have a different outfit, you can simply just change these animations, and then you don't have to worry about going in code and changing it 10 other places that reference these exact sprites. So that's everything in the create event. Let's head over to the next event. So we're going to have 2 more events we're going to create. We're going to have a step event, and then where it says other, animation end event. And so let's go to the step event. And in this particular event, depending on your game's FPS of what it's set to in GameMaker, it should default to like 30 or something like that. And you also should have here in the global variables, or the game options, I should say. If you go to Windows, if you're using Windows, make sure that your graphics are set to, you don't have interpolate colors between pixels. It's going to, if you have this checked, it's going to automatically interpolate colors and your game's going to look a bit fuzzy. If you're making a pixel art game like we are doing here, make sure this is unchecked. But depending on your game's FPS, if your game's intended to be played at 30 FPS, everything in your step event is going to play 30 times per second. And so all this code is going to be ran many times. So what are we going to put inside of the step event? Well, first thing first, what we're going to do is set up our controls. So in GameMaker, if you say keyboard, you can also use these different custom events. Key down, key pressed, key up. But you can also do that in the step event. And in the step event, you have better access. And you don't have to make so many different events for each key, each button. So what we're going to do here is we're going to say keyboard underscore. Let's also open this up too. I'm going to click on the maximize button. So we'll click on keyboard underscore. You're going to notice that it gives a bunch of different built-in GameMaker functions. Keyboard key, and on the left here is what is going to be returned. So in this case, we're going to use keyboard check, and that's going to return a boolean. So we're going to say keyboard check VK. This is just something to remember, virtual keyboard, and these are some of the commands on your virtual keyboard. Left. And so GameMaker is now a bit confused because you're just saying keyboard check left. It's going to return a boolean being true or false. But GameMaker doesn't know what to do with that. So what we need to do is say whatever our variable is going to be called, in this case left press, we can say left press is equal to keyboard check. And if we only want to keep that variable reference within this particular piece of code, we want to toss in var left press. Keyboard check VK left. So what's going to happen is whenever you press left on your keyboard, left press is going to be either be set to true or false. And remember, it's a boolean. A boolean's going to say 0 or 1. Is it going to be 0 or 1? 1 being true, 0 being false. And so what we want to do is we want to create many different keys. So this is just left. We want to create one for right, so on and so forth. I'm just going to copy a bit of code here that I already created and explain what's happening. All right. So here goes setting up our controls. We have left, right, jump press, jump held, down press, up press. These are pretty self-explanatory, but what isn't is this other argument here. And we're saying left press is equal to left, or keyboard, and added WASD for that movement as well, depending on if you want to use WASD or if you want to use the keyboard. And if you want to create movement with a controller, definitely check that up. I'm not going to go over that in this video, but you're going to have to create your own piece of code for that too. And so what we're saying here is keyboard check VK left or keyboard check ORD, I believe it's ordinal. And what it's looking for is it's looking for any string that you're passing in GameMaker, and it's going to turn that, as you can see here, into Unicode. It's going to turn it into a code or a language that the computer can read it, mainly because everyone has a different language keyboard. And so we can't just say virtual keyboard A, because my A may be different than your A on your keyboard. And so we want to use ORD and then A. Whenever you're creating any strings in GameMaker, you want to use these parentheses here, or these quotations. That's pretty much the situation. When it comes to jumping, I put two pieces here. So jump press, this is whenever the spacebar gets pressed once. It only happens once when it's being pressed. The player's going to jump, and if you're still holding, so it's going to check to see if you're still holding the spacebar, we're going to have separate logic for that. So this is in Super Mario, when you jump and you want an extended jump, you tap and hold the jump versus just lightly tapping the space bar or the jump key. There's going to be some logic there. So very basic. We have left, right, jump, up and down. Down's going to be used to jump off of platforms. It's also going to be used to climbing up and down a ladder. And same thing with up press. So next up, we have all these different variables. Well, what do we do with them? Very basic. We can say if left press, remember we're on top of a grid. We're essentially on a grid. So we're saying if left press, you can say equals true, or just if left press, GameMaker will imply this means true. You can say if does not equal true to be false, right? It could be false like this, or you can also be false by putting if not left press, if not true. So if you want to go left, you can tell the player take your own X position and set it to your own X position plus 1, or in this case minus 1. We're moving left, so we're going negative. And so that's the logic there. If you want to move your player to the left, and if you want to move your player to the right, you can do the same thing. Right press, in this case, instead of -1, +1. And so this is how you can kind of create your own movement. You're pretty much taking the character on the coordinates of the game, and you're adjusting its X and Y position. And that's how you're going to create your own game here. But we don't want to use just left press, right press does this, because the code needs to be very versatile whenever we're adding all these extra functions in. We also want to minimize our code too. We don't want to have like 200, 300, 400 lines of code when we can have like 80 or 100. So we're going to delete this. Instead, what I'm going to do here is, there's a few different things. I'm going to try and explain this the best way I can. But what we're going to do here is we're going to say right press minus left press times player X speed. Remember, we set that value up inside the create event. Let's open the create event. I don't know why they're showing up as separate windows, but that's fine. We're referencing something that was created once already. So X speed is set to 2, and we're saying right press minus left press is, but do this function first, times player speed. Pretty much saying 0 or 1 minus 0 or 1 times your speed is going to be how many pixels we want the player to move. In this case, if we're pressing right, that's going to be +1 minus 0. We're moving right. We're moving right into a positive. If we're saying 0 minus 1, we're moving negative. We're moving left. So this is some of the code that we can kind of just make life simple. But what we're going to do is we're going to say var x move is set to right press minus left press times speed. So this, we're going to host a variable called xMove, and this is where our player is intended to move. Now, we don't want to just push the player. We want to first figure out where the player is going to move, and then add some logic, because if we don't add logic, our player can just clip through walls. We need to do something with that. We need to predict where our player is going to go, figure out if our player is going to interact with an object, and then prevent it from doing things we don't want it to do. Next up, what we're going to do is I'm going to copy some code here, paste this in, and kind of just explain what's happening. And we're not going to use this code. I just want to use this for an example to explain the situation. In this code, we have xMove and we have obj wall. Let me update that. Wall. Okay. All right, so we're introducing a new function, and this new function says place meeting. Now, if you type in place meeting, you're going to notice that it's a Boolean. It's either going to return true or false. So what are we really saying? We're saying if place meeting, wherever our x and y position is in the game, if it's meeting a wall, perform some logic. Else, move the player wherever the player is intended to move. Whether it's like left press, whatever logic is left and right happening here. And so let's play the game really quick. And notice we can move left and right until we hit the wall here. We don't have a wall in place yet, but if we go to the room, you can just toss in a wall here, a wall here. I'm going to play this again. And we're pretty much saying if we have a wall, and so let me finish explaining what's happening. If we're meeting a wall and we're anticipating where our player is going to move, so our player, if we're going to move 10 pixels to the right, in this case, we're going to move 2 pixels to the right. If there's a wall there, we want to set a condition to where we have precise collision movement. We don't want the player to clip through the wall, so we want to precisely get to the wall. We're going to say while, so a while loop is going to continue playing until the condition is met. While we're not touching the wall, and we're going to say is x plus sine xMove. So we're saying x plus wherever the x is going. Whenever we say sine, it's going to return either 1, -1, or 0. So if we're saying sine xMove, it's going to figure out are we moving in a negative position left, or are we moving in a positive position right? And so we're saying x plus or minus 1. So we're moving left or right just only by 1 increment. While we're not touching a wall, move the player 1 pixel, move the player 1 pixel, move the player 1 pixel, move the player 1 pixel until it hits the wall. This condition is no longer met. Player move is now set to 0, because wherever you're expected to move, you're going to hit a wall. If you're not going to hit a wall for whatever reason, move however way you wish. X plus equals x underscore move. This also looks like x equals x plus x underscore move. This is the same logic. We're in 2 different ways. So what we're going to do is I'm going to recreate this code, mainly because GameMaker introduced a new function sometime in 2023 called move and collide. And as you see, this is an array. It's going to return back an array. But ultimately, what's happening here, although it's returning an array, you can kind of use this as its own function. And it's going to move for you X and Y position and automatically account for any collisions. So it's going to try and do this code for us. Just so I don't make things confusing, I'm just going to copy some code in and explain what's happening and kind of go from there. So this code works perfectly fine if you want to have collision with the wall. Nothing's gonna break. You can take this code, you can actually duplicate this code and do the same. Instead of doing a Y move, instead of doing an X move, you can do a Y move and add some gravity to it, and then say if the player's Y is going wherever then you can do X, Y, Z. But we're gonna try and implement move and collide the best way we can, because move and collide has built-in slope functions. And so it's gonna try and make our life easier here without adding all this extra code, or at least all of this extra code. And it's not gonna be perfect, but we're gonna use the code to try and simplify this, and then my challenge to you is gonna be add, improve, and depending on your game, you're gonna wanna tailor it and create your own code on top of that, depending on how precise of collision that you'd like. But let me delete this. We're still gonna keep X move. That looks good. But for now, what we're gonna do is continue adding code. So let's paste this in here, and we're gonna say if X move is not equal to 0, so if we're moving, if we're still 0 minus 0 times whatever is 0, right? So as long as we're moving, then what we want to do is set our player to the walk sprite. So we're using a sprite index, which is its own built-in GameMaker function that applies a sprite index to this particular object that we're using and changes it. So we're saying sprite index is now equal to sprite player walk. Remember, in the create event, we already set that up. We said a sprite player walk is set to S player walk. We can also go here and say S player walk, but then if we want to change that later on, we're gonna have to go through code and update that many different places, rather than just going back here and modifying it here if we need to. Or we can have a separate object that modifies it for us. So sprite index walk, you can also do this if you're used to coding with proper syntax. If you don't put the brackets here, it's just going to pick up the first line underneath this function and only execute that. The second line, anything after, is going to be ignored. So if not jumping and not climbing, set the player to walk. And then we're going to introduce another thing too. So this is another built-in GameMaker function here. It's returning back a reel. But essentially what we're doing is we're going to flip the sprite animations. Remember, I mentioned a second ago that when we import our sprites, we're always going to be facing one direction. You only want to create sprites facing one direction and then flip them. Flip them because you don't want to do double the work. You don't want to create right assets and left assets, import them, and so on and so forth. Our player is facing right, and so that means if our X scale is ever set to 1, that means the player is set to 1 by 1, 1x by 1x. In this case, we're just saying image X scale. If we're also saying image Y scale, then the player is going to flip up and down. We don't want the player to flip upside down. We just want the X scale. So in this case, think of it like this. We have our object here, and it's going to flip between +1 and -1. +1 and -1. That's the goal, because we want to either face right or flip the sprites and have it face left. And it's not going to flip how I'm showing you on the screen now. It's going to flip at the origin point, which should be right here at its feet. So it's going to flip, and you're not going to tell that it really flipped. But in this case, image X scale is equal to sign move. Again, sign's going to return either 1, -1, or 0. If you want to make the player larger for whatever reason, you can say times that by 2. The player will be 2 times its size. In this case, you just want to say if the player is, for whatever reason, facing left, if sign move is ever left, because 0 minus 1 is -1, flip the sprites, so that way the sprites are facing left. In this case, we don't have our move logic in just yet, but you can now see we're changing to our walking animation left and right. So next up, we're going to add some more logic in here. We're going to set our idle animations, so paste that in. I'm just going to clean up some of the code just for things to be easily read. So set idle sprite if X move is set to 0, so we're not pressing left or right, and we're not jumping, and we're not climbing. Player's going to be idle. Let's hit play. So now when we're moving, the player is changed to the walk animation. We stop, the player is an idle animation. Alright, so let's introduce the moving collide function I just talked about. So let's paste this in. We're gonna do moving collide X move a wall. And so let's not account for Y movement just yet. We're just doing X movement. And so as I shared a second ago, we had all that extra code to perform the X movement collision. In this case, we don't need all that code right now because we're using this built-in GameMaker function. And so when we move left and right, we automatically have that code applied, where GameMaker is automatically going to do all of that logic for us, which is great. And if you click on here, you're going to notice that it takes in a bunch of different arguments. You can get very specific, modify many different things. And so what we're going to do is move and collide, just X left and right. We're going to ignore Y for now and toss in a wall. We just want to collide with just the wall. And so that's that logic. If you guys want to add that in there, we're going to add it in later in just a few minutes. So now we need to figure out our jumping situation. So I'm going to paste some more logic in here. Oh, wall one way. And this may be a bit confusing, so let me explain it the best way I can. And what we're saying here is that we're creating two variables, one way object that's equal to instance place. As you can see here, it's going to return pretty much an object asset, whatever it finds, and return that back as this variable. And we're pretty much saying instance place x, y plus player y speed, O wall one way. So we're trying to detect if player speed is moving towards a one-way wall. And then what we're going to do is say on top of one way. So this is going to be, are we on top of that one-way object, yes or no? So in this case, top of one way going to be a true or false return. So trying to make that one clear here. So we're going to say if this object, when we say no one, not equal to no one, we're saying this object exists. If this object if we found an object, and you can also use and here or A and D, they both mean the same thing. And self.bBottom, self is going to reference the object itself, the player. Since we're in the player code, it's going to reference itself. .bBoxBottom is less than or equal to one-way object .bBoxTop. So what we're saying here is we can probably take our Y origin point, because remember we set the origin point to its feet, the player's feet. But in this case, I put bBoxBottom. It's going to take the bottom pixel of that particular sprite and say if it's less than or equal to the top plus 1 of the one-way sprite. And I put +1 in case if you guys want to scale the object, it can account for at least that pixel. Then set this to true. So we're pretty much saying one-way object, if we can find a one-way wall anywhere, then that's collect its data, and then say, all right, now give me a true or false return if that object exists and the player's above the object, the player's feet are above the object. Well, now we can do something. And so what are we going to do? We're next up going to put this piece of code in. And so now what we're saying here is we're starting to add some of that vertical collision and movement. And mainly we're just adding this because we want to be able to account for the one-way object. So we're saying a place meeting XY is wall, or place meeting is top of one way and not down press. And so here, remember we had that while loop earlier. We had while X moving towards the wall, move increment 1 by 1 by 1. If you want, you can add the same logic in here. But again, we have that move and collide function that we're going to use. So we don't have to add that precise move 1 pixel, 1 pixel, 1 pixel. However, we still want to account for this wall one way, or player is standing on top the one-way wall, wherever the player speed is going to be. Set the player speed to 0. And if jumping, create this player land jump. So we're landing. We're saying stop the player's Y speed and land the player now. And we are pretty much done here in terms of XY collision. Next up, what we're going to do here is now toss that right back in, the moving collide function. I broke this up into two different pieces because the X movement and the Y movement, you can create your own variables and treat them however way you wish. However, when I tried to do them both together, moving collide X and Y combined, I wasn't getting the results I wanted when I started modifying how fast the player can move and fall speed and all that. So I just broke them up into two different functions here. Moving collide for the Y speed, for gravity whenever the player's jumping, and then X move. X move we just went over a second ago. copy that over, that everything else looks good. And then Y speed with the player Y speed. And then I kind of just put some arguments here. I'm going to change this to 4. This is default. And kind of just follow along with me. This is moving collide X, Y with obj O wall. This is a default variable. Those are just 0 for now. And then player max fall speed. This is how fast the player can fall. So this moving collide is automatically going to take that logic for us. We don't have to manually go in and do any extra checking of some sort. So the only thing we haven't added in yet is the player gravity. So we can keep track of player X and Y movement together. So we're applying gravity. We're saying player Y speed is equal to itself plus gravity. Now remember, if we're adding to anything, we're going down. So it's just saying add gravity. Continue to add 0.35 to Y speed. And Y speed's going to say if you ever jump, let's say you jump and now you're at 7, positive 7, gravity is going to start to be applied over and over. And so now we have a Y speed that actually has some logic to it. It's pretty much itself plus gravity applied to its own self. Going to hit save, play, and there you go. We don't have jumping logic in yet, but we can collide with this wall and we can collide with the ground and everything looks good. So next up, what we're going to do is we're going to add some more logic here. But first, let's go here and say if not climbing. You can also later on add other conditions depending on your game, depending on what you want to do. But for me, whenever if I'm climbing, I don't want the player to automatically fall and have gravity, and I also don't want the player to move left and right. I just want it to move up and down when climbing. So I'm going to say if the player is not climbing, then you can move for free. And then in your game, you can also say and, you know, not attacking or something like that. Depending on the situation, if you're pretend you're gliding or something like that, you want to have its own set of rules for gravity. But in this case, this is just going to apply the movement and collision code for us and try to make life easy. So the code may look a bit confusing, but a lot of it is really just conditions and adjusting sprites and things of that sort. So next up, I'm going to add the jump logic here. Let's paste that in. Jump press. Again, we have this obj wall. Kind of created the code like that. Just put that in. Whenever you jump, the player needs to be standing on a wall or standing on a one-way wall. Now we're going to add the jump speed. So 7, well in this case -7. We're going to say Y speed is now equal to -7. So jump up. Image index is 0, because what we want to do here is when we're jumping, we want to reset the sprite. When we reset the sprite, we want to start it off at the very first frame and then add a condition. Jumping is now set to true, and here goes the sprite that we want to use. So let's play this. Let's see what this looks like. Now we have jumping in place, but you're going to notice that the jumping frame land, and we also have other things happening here too. We can jump, and it's just playing the whole landing animation now. It's not really turning over to the next frame. And so up here in this piece of code, jumping and we're landing, remember we said we were landing, play the player land jump animation. But what we also want to do is after the player land jump animation is over, we want to say, all right, jumping is now set to false. We're done with jumping. And so what we need to do next is we're going to go and use another event here. And in this event, we're going to go to other and go to animation end. And so in animation end, we want to account for two conditions. If sprite index, so we're going to adjust, we're going to do a condition and then adjust what's happening. Sprite player land jump. If sprite index is sprite player land jump, so if the player is going to land their jump, what we want to do is we want to say jumping equals false. And set it to whatever. We can set it to idle for now. sprite idle. Why do we want to set it to idle? Because we want to change the animation to something else. We want to force the animation to be anything other than landing jump. If the player's not pressing any keys, they should go to the idle state, but in this case, it'll automatically change to the idle state, and then depending what the player's doing, it'll change to whatever other state is happening, or the frames. But remember I mentioned a second ago, there's two things we need to account for. When we're jumping, we don't want this to play over and over. Pretend we're falling into this, we're falling down. We don't want this to play again and again and again. We want the player to do this once and then stay like this in the air until they land. Let's say you're doing a very large jump. The only way to do that is to utilize, again, this animation end event and say if sprite index is equal to sprite player jump, all of a sudden image, we're going to say, so now we're saying if our jump animation has ended, we've determined that we're jumping and our jumping has come across its very last frame. We're going to say image index is going to be equal to, so we're setting the index, not the sprite index, whatever sprite it's going to be. We're going to set the frame. Which frame is it going to be? We're going to say keep the player on the very last frame. You should be able to just set it to 5, but in this case, if you're going to put your own frames in, you want to be more clever than that. So we're going to use image underscore number. Sorry, not, put that wrong. Image underscore number -1. I mean, why -1? Image underscore number is going to get you a total count of frames, and you want a -1 to stay on the very last frame, because it's going to count in zeros. It's going to start off as like an array. Start off at 0, 1, 2, 3, 4, 5. It's going to count 6. And you want to just say -1, keep it on the 5th frame. And so now, if we play our game, hopefully, there we go. When we jump, we now land. And notice that a second ago, when we were jumping, we didn't switch frames. I'm going to play that one more time. We're going to take a big jump here. Look, stay at that frame, then we land. We don't want the player to continue cycling through the jump animation mid-air. That will not look good at all. Alright, so we have a lot of the logic in place already, but let me add one more thing in, and this is optional if you guys want to do this. And pretty much what we're saying here is we're going to use what I call Super Mario jump logic, where if you tap and hold, you get the full jump, or if you do like a very light tap, you're just going to do like a soft jump. Alright, so we're going to add a condition here. We're going to say if we're jumping and we're not holding the jump key after we jump, and the player is Y speed is less than 0, then we're going to reduce the player's jump. And you can kind of modify this however way you'd like, depending on how short of a jump you want. But yeah, pretty much we're saying we're going to jump and we're going to apply this extra bit of gravity to the player unless we're holding our jump key. Then you get the full jump, the full height of the jump. Let's hit play, and this is optional. You can turn it off if you like, but we do a jump here. I'm jumping and holding, and I'm going to do a very light one here now. Extra gravity is applied. Tap and hold, that extra gravity is no longer applied. Very basic, very simple, straight to the point. Next up, we want to finish off here with some ladder climbing logic. I'm just going to copy and paste some more code. And I had to create it like this because I wanted to create different conditions of the ladder. So let me explain what's happening here. If we're meeting a ladder, and let's go to our ladder object. And in our ladder object, our collision mask, we want to set this to manual. And we want to set it to manual because we don't want our player to start climbing as soon as they can collide with the object. We want the player to start climbing a bit further into the object. So we're going to set the collision mask to something smaller, maybe something like this. So that way the player really needs to walk closer to the ladder to really detect it. I'm going to click Control S. We'll tap on Control S there to save. Or in code, you can just go to the origin point and then compare it and say if you're close to the origin point of the ladder, you do X, Y, Z. So there's two ways to tackle this. You can kind of do it like this, where you modify the collision mask so the player needs to get closer. Or you can say, well, the player needs to get close enough to the axis of the origin point, whatever. So in this case, we're saying if place meeting ladder, if climbing. So climbing is not set to true yet. What's going to set climbing to true? If we're going to press up or if we're going to press down. Now for pressing up, player climb speed, again, we're going in a negative direction, so we're going to go up. Player climb speed is down, we're going to go positive. As soon as climbing is set to true, we now say image speed is set to sine of whatever we press. Remember a second ago, sine means it returns either 1 or -1 or 0. So we're saying in this case, our sine is going to be equal to down press, or we're not going to do any math here saying plus or minus, we're just saying or. So if either of these conditions are true, they're going to be 1. If they're not true, they're going to be 0. Image speed 0 means the player is just going to stop animating while climbing. If we're not pressing up or down, the player is just going to stop on the ladder. Image sprite is set to sprite player climb, so the climb sprite's going to continue to be climbing. And then lastly, we're going to say else if. So we have two conditions. Either you're going to press down and you're going to get to a point where you need to get off the ladder, or you're going to clip into the ground, like start climbing towards into the ground, or up press and we're above the ladder. So we are now 1 pixel above the ladder. Climbing is equal to false. And so here, what we're saying is self dot, another function here, that's new, sprite height. We're going to say how tall is a sprite, and if we're moving down the ladder, if our sprite is tall enough, then just fall. Climbing, we can't climb anymore. So climbing is false. And apply gravity again, the player's just going to fall down. Or if I'm pressing up and we're now above the ladder, we want the player to fall. Else, image speed is equal to 1, climbing is set to false. If we're no longer near a ladder, that means the game you can move as normal. Or climbing is set to false. You can probably clean this up better, add better logic in place to handle that. But that's the way I did it. And lastly, I don't know if I talked about this one, but going back to this logic here, if you are on top and in like of a one-way object and you down press is all of a sudden set to true, it's gonna apply gravity. So this function kind of allows you to do that one-way drop and also force the player to always Y speed set to 0. And so there you have it. And you can do Control S. Lastly, we just need to toss in. We already have those crates in here. Cool thing with the ladder code is that notice that we're not looking for any conditions here, for any walls. So the idea is if we're climbing a ladder, you can go through any object you want, wherever the ladder is. It's going to take that preference and kind of climb that way. If you want to add collisions, then you can kind of do that here as well. But that's why I specifically went up here and said if not climbing. So we turn off all collision logic, because if we're climbing, we want to go through platforms. That's the whole idea. Open this up. We're going to toss in a ladder. And the idea here is, I'm going to try and put the ladder top, but we're going to say, pretend this is the ground. I want the ladder to be like 1 pixel above, so we can climb up, detect nothing else, and then the player should kind of drop or stop or whatever. So let's play this. And I also forgot to test out these. These are the one-way collisions, well, one-way platforms, where you can walk through, land on top, press down, and you'll just drop below. You can add some logic in it. If you press down, maybe you can change towards a sprite or a falling sprite if you wish. But let's lastly test out this ladder here. So we go up, player stops as soon as it gets above because it can no longer move up, down, and then the player kind of comes down. In this case, the collision is too close, so the player looks like it gets clipped here. In that case, if you want, you can just kind of update the collision mask to make it smaller, and this should work. You can also toss in a one-way here, rather than just do this collision, do like a one-way collision. But let's toss this in, just make sure everything works. So we go up, down, player falls on its own, go up, you can land on this one, press down, player falls down, player can also jump through it. And I don't think we've added collisions on that one yet, but we added collisions on here. And there you have it. That is pretty much the whole tutorial. We can add many more things here. As you saw in the demo, there was like an information post. And so, again, that's my challenge to you. Create an enemy, slope logic, double jump logic, many different things that you can think of. Just start adding them into the game. And if you want to get very precise, another thing here, like slope logic's already in the game, as I showed, but you need to modify the slope logic, because what GameMaker does here for that particular player, when you use that move and collide function, it doesn't do a good job at detecting slopes when moving down. It can detect slopes moving up. When you're walking down, it's not going to try and clamp the player to the ground. So in that case, you want to try and modify that around here. When you're landing on something, you want to try and maybe clamp it down a bit. Maybe we can do like moving while something happens. Probably also do a modifier here where you're moving left and right. Maybe the X axis, like when you're moving, can detect some of that stuff and modify it for you when moving up and down slopes. However, it can get very technical when you're working with slopes, and so I kind of avoid them, at least from like a tutorial perspective, because it just gets very complex. Then you need to modify the player's angle if you wanted to go that route, or modify a player's sprites for when walking up and down slopes, attacking up and down slopes, then take that into account for the enemies. There's just so many things that can kind of go wrong, so many issues. So that's pretty much it. If you guys enjoyed the video, let me know. If you want me to create a second part to this and add a bunch more features, let me know as well. But we'll call it a video for now. Until next time, bye.